Hello! So we've still got the same set of equations of lines, so the vector equations of lines, but this time we've been asked to determine, giving reasons, the geometric relationship between lines A and C. So here's line A and here's line C, and we've been asked to find the geometric relationship. All that simply means is, are they parallel, do they intersect, or are they skew? And I explained all of that in the last video, just to give you a brief kind of overview to make sure we're all on the same page. If they are parallel, it means that we kind of got this thing going on. Okay, so they never meet because they're like running exactly sort of like that to each other. And if they're parallel, remember that the direction vectors are the same. So I've got vector equation of a line plus t lots of b minus a, okay? The direction vector bit is this bit in here. If they're parallel, it means that the two lines have the same direction vector, or just multiples of the direction vector. So essentially they're the same, okay? And one might be longer than the other, but essentially they're the same direction, okay? If they intersect, so we've got this thing going on, then what that means is that with the two equations of the line, so in this case, there's a value of s and a value of, in this case, u, that works in both equations, okay? So in other words, we basically have a system of three equations, okay? We solve the first two, find out what t and s is, and then that should work in the third equation. And I showed you an example of that in the last video, okay? And then if they're neither of those two, so they're not parallel and they don't intersect, they must be skew, which literally means they're sort of looking like that, so they sort of never meet, basically. Okay, so determine, given reasons, a geometric relationship between lines in A and C. Now, if you're faced with this question in the exam, don't start with intersection, because that takes longest. Okay, remember the way to show that they're skew, they're not parallel and they don't intersect. Okay, so skew is an easy one to do. So actually, you only need to look at two things. If it's not the first two things, they're not parallel, they don't intersect, then they must be skew. Okay, but don't start with intersect; it just takes so long. Start with parallel. So that's basically what's going on here, because we need to determine whether they're parallel, whether they intersect, or whether they're skew. So let's start with parallel. Okay, so remember, if they're parallel, then the two direction vectors must be the same. So let's have a look at these two lines. Okay, then it means that direction vectors, which is this bit here, must be the same. So let's have a look at these two lines. So I'm just going to write them out. Remember, IJK notation, I get it, it's kind of fine, but I prefer to see them as kind of like proper vectors. Okay, so line A, we did that in the last video. It literally just means one in the unit direction of I, so that means one across. Then 4 in J, so 4 up, and then we go 1 in K, so that's 1 outwards, isn't it? Okay, and then we go S units, or S multipled, so S just like a number, it's that kind of length, so S units in the direction of negative I, so that means -1 in the I direction, so it means not going 1 across anymore, we're going 1, so not going 1 to the right anymore, we're going 1 to the left. Okay, so that's -1. Then we go 2 in the J direction, so that means going 2 up, and then we're going 2 outwards, so that's 2 there. Notice as well that all I just have to do is just take the coefficients of I, J, and K. That's how I get these numbers. But I'm just kind of trying to be awkward to show you what's going on. Okay, so let's do C then. Let's do C. Oops. Let's do C. So we've got -1, 19, 15. Okay, and then we move U lots of 2, -4, -4. Okay, so I want to show that first of all, are they parallel? I'm asking the question, are they parallel? If they're parallel, well, what that means is I just need to look at the direction vectors and they should be a multiple of each other. So let's have a look. So I've got -1, 2, and 2. That's my direction vector of the line A. The direction vector of my line C is 2, -4, and -4. Okay, so let's think. What do I have to multiply? What do I have to multiply -1 by to get 2? Well, -1 times, not 2, but -2 to get rid of that negative, okay, will give me 2, okay. Then what do I have to multiply 2 by to get to -4? So 2 times -2, isn't it? Okay, because a negative to make it negative, and then 2 to make the 2 into a 4, okay. Then what am I going to have to multiply 2 by -4 again? That's again multiplied by -2. So because these are all the same thing, they must be parallel. So therefore, they must be parallel, right? So how would you express in the exam? Determine given reasons. So you say, well, first of all, they're parallel. That's your first mark out of the two. The second reason is because the direction vector of B is just -2 times the length of the direction vector of A. So basically just stick that down in the exam and you've got yourself 2 nice marks.